In this question, we've been asked to evaluate this expression, and we can either achieve that by multiplying out the bracket first and then combining the fractions, or we could combine the fractions inside the bracket and then multiply the bracket. Either way is fine and will involve a similar amount of working. I'm going to choose to leave the 2/3 outside the bracket, and I'll multiply the bracket out later, and I'm going to combine my fractions inside the bracket first. So these do not have a common denominator. Because we're trying to add them, you need to make a common denominator, so that's going to involve making two new fractions. You make the common denominator, remember, by multiplying the existing denominators together, so these new fractions are going to be 20ths, and to make the numerators you're going to cross multiply, so 4 times 1 gives us 4, and then 5 times 3 gives us 15. Or you could think of that as just multiplying that top fraction top and bottom by 4, in other words the opposite denominator, multiplying this fraction top and bottom by 5, so the opposite denominator. Either way you're going to end up with this here. So the 2/3 we can just leave outside the bracket for the time being. We just want to add these two fractions together. These are 20ths. 4 20ths plus 15 20ths gives us 19 20ths. Remember, it's not 19 40ths, you don't need to add the denominators together. So now we're multiplying out the bracket, which essentially really just means multiplying this fraction to that fraction. When you're multiplying fractions, you don't need a common denominator, so you can just multiply the numerators and the denominators together. So 2 times 19 gives us 38. 3 times 20 gives us 60. So we're almost there at this point. We just need to check whether that fraction will simplify down. These are both even numbers, so just start by dividing by 2. Sometimes you can only divide by 2, so don't be too ambitious in looking for a higher common factor. 38 divided by 2 is 19. 60 divided by 2 is 30. That won't go any further, so 19 30ths, 19 over 30, that's our final answer. In this question, we've been given this function, f of x, and we're asked to evaluate f of minus 3. So remember that a function is just a fancy word really for a formula. This is a formula that says that you can take any x value and put it into the formula, which really means just replacing all the x's in the formula, in the function, with whatever the number is you're evaluating. So when we come to evaluate f of negative 3, that really just means that we're replacing all the x's with negative 3. There is only one x in this case. If there were multiple x's, you would need to replace them all with negative 3. So this first line of working will just be negative 3 cubed minus 2. So notice that what I've written there and what was in the original function have got the same structure, the same form. All I've done is replace that x with the number that we're evaluating at. Be really careful not to rewrite this as f of x. As soon as you change that to a number, that has to also be the same number. So the x and the x are matched up here, and the number are matched up there. So now we just need to evaluate this. You would get 1 mark already for making that substitution. Now we need to turn this into a simplified final answer. Negative 3 cubed, that's not an easy one. Be careful with the numeracy there. Remember that a number cubed, like negative 3, really just means negative 3 times negative 3 times negative 3. So feel free to do a bit of side working with that if you need to. So negative 3 times negative 3, that's a double negative to give you 3 times 3, which is 9. So essentially this part here becomes a 9, and we're still multiplying that to the other negative 3. 9 times negative 3 is negative 27. So when you take a negative number and you square it, it becomes positive. When you cube a negative, it stays or goes back to being negative. Okay, so that's going to be negative 27. We've still got the minus 2 in the end. Minus 27 minus 2 is minus 29. And that's the final answer for that one. In this question, we've been asked to calculate the volume of this cone. So the formula for a cone is on the formula sheet, so we're going to be essentially plugging into the formula. So the formula says that the volume is equal to 1/3 pi r squared h. So you might remember that pi r squared h is just the formula for the volume of a cylinder. So we're just putting a 1/3 to turn that cylinder volume into the cone volume. You can see they're sort of similar shapes. So basically we need to gather together the things that we need to put into our formula, which should be in the question in some way. So we're told here that the diameter is 20 centimeters. This formula doesn't have diameter, it's got radius. So we need to half that. So the radius, the number we're interested in is 10 centimeters. That takes care of the r. Pi is just the number pi, which we're going to be using as 3.14 to use a decimal version of pi rather than just the pi button on the calculator. And then the height is just this vertical height here, which is given directly in the question. So the height, the h value is 60 centimeters. This is quite a challenging question, not to set up, but for the numeracy part, because we need to calculate using not the pi button on the calculator, but the number 3.14. But these questions, you should really just start by gathering the information you need, put it into the formula. You're going to get a mark for that probably anyway, so I'm just going to put these numbers in. So the volume is 1/3 times pi, so I can write that in as 3.14 times r, which we said was 10, remember? So it's going to be 10 squared times the height, which is 60. So it's often the case in these questions that if you need to use r, the radius, they'll give you d, diameter, or vice versa. So watch out for that. That's just to try and make sure you're being attentive to the fact that this is not the value you need for the formula. So really this is now a numerical question. It's about numeracy, which is not necessarily easy, but there's a couple of tricks that we can work on to help with the numeracy part. It would be easy if it was in the calculator paper, but this is a non-calculator paper. So always start these by trying to fully simplify the numbers before you work with the difficult number. The 3.14 is the thing that makes this difficult. You want to leave that until the end, basically. So what I'm going to do here is I'm going to reorder the terms. So I'm going to put my 10 squared and my 60 here, and then just put the 3.14 on the end, because I'm not worried about that just now. I want to deal with that later on. If you start by using this number, it's just going to make more decimal numbers, and then that means the rest of the calculation will be more difficult. You only want to use that decimal number one time if you can possibly achieve that. So looking at these numbers, and by the way, I should say that these are all multiplying together, and the order in which you multiply doesn't matter. So that's why I'm allowed to change the order. Like 1/3 times 3.14 is the same as 3.14 times 1/3. The order doesn't matter. So we can now simplify by saying that 10 squared is 100, so that's going to be 1/3 times 100 times 60 times 3.14. And there's an element of personal preference in these. Not everyone will perform this calculation the same way, but just look for the most logical thing. So 1/3 times 100, that's not a great idea because 100 doesn't divide by 3. 60, however, does divide by 3. So I can think of this instead as being, again, reordering things, 1/3 times 60 times 100 times 3.14. A third of 60, that's just dividing 60 by 3, that's 20. So it's going to be 20 times 100 times 3.14. So we can see that we're kind of narrowing in the working as we're going. 20 times 100 is 2,000. So that's 2,000 times 3.14. So the first little trick here to pick up is don't use the 3.14 until the very end. Second thing, obviously we still need to finish off this calculation. Second thing is, if you've got numbers that have got a bunch of zeros on the end, which quite often these questions do, just ignore the zeros. You can add them in later. So just imagine this being 2 times 3.14. So 2 times 3.14, let me just do that at the side. So 2 times 3.14, well, that's just going to be 6.28. If you then want to multiply that by 1,000, put the zeros back in, you can just change the decimal point. We could change it by going 1, 2, 3 places. So that's going to end up being 6, 2, 8, 0. So if you imagine a 0 there, moving it 1 place, 2 places, 3 places, it would end up there. So that is the final number. Remember, we were working out volume here. So volume for this case, because the lengths were given in centimeters, will be centimeters cubed. So 6,280 centimeters cubed is the final answer. So we've been given this geometrical situation, and we're being asked to find the angle A to C to E. First thing to be careful here is that you actually pick up the correct angle that you're trying to find. So a lot of students will misinterpret what the angle is. So remember that if you're asked to find something like A to C to E, you're focused on the middle letter. That's the one where the angle is going to take place. So it's the angle between here to here to here, which means that it's essentially the angle from that tangent line all the way past the circle to this line here. So it's essentially this angle here that we're trying to find. Generally in these questions, you don't find the angle directly. You find it by finding other angles and then maybe adding them together or kind of combining them in some sort of way. And in this case, we can see that our angle, it kind of spans over to this line and then this part of the triangle. So we're going to take an approach where we find two separate angles and add them together. So this angle here, which is the one from the tangent line to this radius line, and then secondly the angle inside the triangle. We're going to use some geometric properties to achieve that. So if you ever get a question of this nature where you've got a tangent line, the tangent line rule is that it makes a 90-degree angle with the radius line. So the angle between A and C and this center point, which is O, I think. So center point O. So basically the angle, this is our goal. I'll just leave that up there. That's what we're trying to get to. So A to C to O first of all, and make sure you write down your angles and you're working in these questions. So just by the geometric rule of the tangent line and the radius line, we know that that's a right angle. So no brainer, you can just write that one down, 90 degrees. And if you get a tangent line in these questions, it's going to refer to that 90-degree rule. That's the only rule to do with tangent lines. So that means that to solve our overall problem, we now just need to find this angle in here, and then we can add it to that 90 degrees to get the total angle A to C to E. So now we turn our attention to somewhere else, and obviously they've given us that 68 degrees for some reason, so we need to focus on that. But that's part of a straight line here. If we were to then take the other side of that angle to complete the straight line, well, we know that the angles in a straight line add up to 180. So we could do another bit of side work in here. So if we do 180 minus 68, that's going to give us 112 degrees, which is this angle in here, 112. Some students like to write on the angles on the diagram as they do that. That's up to you if you wish to do that. And again, just maybe label that. So that's going to be the angle C to O to E. So we could say that C to O to E is equal to 112 degrees. So remember, we're trying to get to this angle here, but if you notice that in this scenario, which I've tried to replicate and probably not done a great job of, this scenario here, we've got this line, which is part of the triangle, but it's also the radius line of the circle. And this line here is also part of the triangle, but again, it's the radius line. Now, my diagram is not perfect, but in the actual diagram, these should, of course, be the same length because they're both the radius. That line there's a radius, and that's a radius. Importantly for us, that means it's an isosceles triangle, and that then therefore means that the two angles are also the same. So this angle here and that angle there are the same angle. So we know that the angles in any triangle add up to 180. So if we just assign a letter to that angle, let's just call it like little a for angle or something like that, then we know that if we take that 112 and we add to that the two little angles, so that'll be 2 times the angle A, that has to add up to 180 degrees because the angles add up to 180 in a triangle. Essentially that means that the 2A is equal to 180 minus 112, which is the reverse of that calculation earlier, so that gives us 68. And you don't have to necessarily do this as an equation like I've done. You could just look at it and start to work it out as long as you show a little bit of work in. You could do it by kind of numeracy. I'm just sort of showing the formal process. Then we could half that, divide both sides by 2, and we get that the angle there has to be 34. And you could achieve that just by saying, right, well, if this is 112, then that 2 angles added together has to be 68, and because they have to be the same angle, then it has to be 34. So that the angle that we're looking for there and there is 34. So that's going to be the angle, what should we call that one? That's going to be angle A to C to E. So angle A to C to E is equal to 34 degrees. So that now gives us that one plus the 90. So we can go back to our original question and say that A to C to E is going to be that angle there, the 90. And we're going to add to that the one that we just figured out, the 34, plus 34 degrees. So that gives us 124 degrees as our final answer. I would really encourage you with these geometry questions, or any questions got a diagram actually, like Pythagoras or a whole bunch of other things, just make sure your answer makes sense. I see a lot of students write down nonsensical answers, like clearly this angle here is more than 90 degrees, but not massively more than 90 degrees, so it should be 100 and something. It's not more than 180, because that would take us all the way around to there. So 124 looks like it could be in the right place. If it looks like it could be in the right place, it's a good chance it might be. If it definitely doesn't look like it's in the right place, then it's definitely not going to be. So a quick visual inspection just to make sure your answer does actually make sense. So 124 degrees, that's the answer for this problem. In part A of this question, we've been given this trinomial, and we're asked to write it in completed square form. So completed square form is a kind of factorizing, and really you just need to remember the steps. There's no real magic to this. You can't work it out on the fly. You just need to know how it goes. And it goes like this. It's quite a simple process, but it's not simple to remember. So we start by just putting an x in the bracket, and that's always going to be the case. take the number in front of the x, the coefficient of the x, and half it. So always doing this, so half of positive 8 is positive 4, but if that had been a negative 8, you would put a negative 4, so half that number and then put a squared on your bracket. And literally you will do that every single time, so x in the bracket, half the number, put a squared on the bracket. And then there's different ways to then finish this off, depending on, well, teachers will teach it in different ways. There are a few different methods. So I personally prefer the method where you then subtract, and it's always going to be a subtract, but you subtract the number you've just put in the bracket squared. So 4 squared is 16, so we do subtract 16, and just leave the 15 on the end. And then we just need a second line of working just to tidy up the numbers on the end of the expression. Negative 16 plus 15 is negative 1. And that's pretty much all that we're doing by completing the square. If you multiplied out that bracket, so that bracket squared means the bracket times itself, if you multiply that out and gather the terms together, all of that would end up being that. So the original thing, the trinomial, and the completed square form are the same thing, just written in a different way. So it's a form of factorizing. Just got to learn those steps, and they're not that difficult, they're just difficult to remember. So that's part A of the question. In part B, they've taken that trinomial and they've turned it into a function. Sometimes these functions will be written f of x, but remember, this is a quadratic function, which refers to a parabola graph. So quadratic functions make those U-shaped, remember, parabolic graphs. And sometimes the formula is written f of x, and sometimes it's written y equal. So don't be confused by the f of x and the y. They essentially are the same thing in terms of the graph, but just slightly different notation. Anyway, in this question, we're trying to find the coordinates of the turning point. And this question is really just a state question. It's not a question where you really need to do any work in, because in part A, we realize that the function, the trinomial, which is the same in both parts of the question, we've realized that that can be written in the form x plus 4 squared minus 1. And if you've got a function, a quadratic function written in completed square form, and this is the whole point of part B of this question, these numbers give you the coordinates of the turning point. So this is our f of x, and again, this could be a y rather than an f of x, it doesn't matter. But the 4 and the minus 1 give us essentially the turning point, and you just need to remember that the number in the bracket, you change the sign on that number. So the turning point, I'll just call that TP, for this parabola would be at minus 4, minus 1. So the number in the bracket, you change the sign on. The number outside the bracket, slightly confusingly, you don't. So the coordinates of this turning point for this parabola, minus 4, minus 1. Look out for any question that's worded state. If a question doesn't ask you to calculate or work out, if it just says write down or state, there shouldn't be any working to do. Because notice I've not done any work in there. I've just used interpretation and my knowledge of the fact that that turns into that. So minus 4, minus 1 is the coordinates of the turning point. So we've been given these 2 points and we're asked to find the equation of the line that passes through those 2 points. So to find the equation of a line, you essentially have to find 2 things. You've got to find the gradient and the y-intercept. There's a couple of different methods, a couple of different formulas, but they're very, very similar. I'm going to show both methods because you may have learned this technique in one of those 2 ways, or perhaps you've learned it both ways. But regardless of which technique you use, you're going to start by finding the gradient. And the gradient formula, remember, requires us, or at least it's good practice, to label your points. So I'm going to call this one x1 and y1, and this second point x2 and y2. The formula for the gradient, which we normally notate with an m, remember, is y2 minus y1. So that's basically the vertical change, so sometimes called the vertical, over x2 minus x1, which is the horizontal change. So just plug in your numbers. Be really careful with this. It's easy to miss double negatives and that sort of thing. Remember, these formulas have already got negatives in them. So y2 is 7, so we get 7 minus y1. y1 is minus 1, so it's 7 minus minus 1. So be really careful with that. And then x2 is already a negative, so it's minus 5 minus x1, which is also a negative. So lots of negatives here, so that's minus 3. So one thing I would really recommend doing, I mean, this question doesn't come with a diagram. A lot of the straight line questions do. If they don't have a diagram, you might want to just draw your own little diagram real quick. I mean, it doesn't have to be too artistic, just a quick sketch. And let me show you why that is important. So just a little XY axis like this. So just mark on the points roughly. So minus 5, 7, that would be like minus 5, 7 is up here somewhere. Minus 3 minus 1 would be like roughly down here. So our line looks like it's going to go something like that. So what does that tell us? Well, it tells us that it's quite steep and going that way, which is a negative gradient. So it should be a negative number, and it should be a number bigger than 1, because gradients of 1 or minus 1 tend to be, well, are at 45 degrees, so they're fairly not too steep. This one should be a number bigger than minus 1. So 7 minus 1 is 7 plus 1, which is 8. And then on the denominator, we've got minus 5. Minus 3, that's plus 3. So it's minus 5 plus 3, which is minus 2, like this. And then that gives us minus 4. And that minus 4 gradient, that tallies up with our diagram, which is both steep and negative. So gradient of 4 and a negative 4. So be really careful with that. It's so easy in these equations, in this formula in particular, to miss double negatives. That's why having a diagram or drawing your own diagram can be really helpful. So some students will then proceed using the formula y minus b equals mx minus a. To use this formula, you need to choose one of your points and nominate that point as a and b. Doesn't matter which one, so I'm going to use this one as my a and this one as my b. So I'm just plugging those numbers in. So y minus b, so that's y minus 7, equals m, which is the gradient, which is minus 4, x minus a, which is minus 5. So again, watch out for that negative or double negative. So just try to simplify from there. So I'm just going to leave the minus 4 outside the bracket. X minus 5 is x plus 5. And then you can multiply the bracket. So just making one change per line. Keep it nice and simple and logical. Minus 4 times x is minus 4x. Minus 4 times positive 5 is negative 20. And then just add in 7 to both sides to get y equals negative 4x. Remember, you're looking for y equals mx plus c type format. That's what the equation of a straight line looks like. So add in 7 to both sides. So negative 20 plus 7, because remember you're adding 7 to both sides, would be negative 13. It's also useful at this point to go back to your diagram if you've got one in the question or you've drawn your own one, because remember that n number is the y-intercept, the c value, the y-intercept. So if you look at the diagram here, that is intercepting the y-axis down there. That could be minus 13. So if this had come out to be plus 13, well, plus 13 will be way up here somewhere. That couldn't possibly be right. So all this, all that we've got here in our equation fits in with the diagram. So just to show the other method, in case this other method is what you use and this seems confusing, not everyone uses that formula. You can just go straight to the y equals mx plus c formula. In this case, you are going to plug in the gradient, which is still the same, minus 4. And in this method, we're just trying to find the c value by selecting one of our points. You can use the same point, but instead of thinking of it as a and b, we're just thinking of it as x and y. So without the numbers, I guess, it's just an x and a y. So my y value here is 7, so I put a 7 here. Minus 4 is minus 4x, but remember that means minus 4 multiplied to x. The x value here is minus 5. So it's going to be minus 4 times minus 5 plus c. Essentially, this method turns in a little equation to then solve to get the c value. So you need to solve this as an equation. Minus 4 times minus 5, that's a double negative to give us 20. And then we can just take the 7 away from both sides, so we get c equals 13. And that gives us our final answer, and then we can just add that into the equation. So we just then subtract 20 from both sides. 7 minus 20 is minus 13, and that's our c value. Then just putting that back into the equation, so we then get a final answer, y equals minus 4x minus 13. So you should get the same answer both ways. It just depends which way you've learned to go about that technique. One argument for not doing it this way is it involves solving an equation. You should be able to solve equations in National 5, but a lot of people don't solve them very well, so maybe this method is preferable, but it just really depends how you've learned it. So that's the final answer, y equals minus 4x minus 13. In this question, we're being given this formula and we're being asked to make b the subject of the formula. So at the moment, d is the subject of the formula, so we need to rejumble the algebraic terms to make b the subject. Essentially, making a letter the subject means getting a letter on its own. So at the moment, d is the subject. Because it is on its own, we want to make b the subject. So that really means that your focus is not really on the b, it's on moving all the other things away from the b. Because if you can move those away from the b, leaving the b on its own, then it will be the subject of the formula at that point. So a lot of people focus on the subject letter, but really it's all the stuff around it that you need to focus on. The first feature of this formula is the fact that it's got a fraction. So any formula, any equation that's got fractions, you really want to get rid of the fractions. Otherwise the algebra can be quite cumbersome and difficult. So to get rid of this divided by c squared, we need to multiply both sides by c squared. So multiplying on the left hand side by c squared, multiplying on the right hand side by c squared. So d times c squared just gives us dc squared. On the right hand side, if you multiply this fraction by c squared, it just cancels out the dividing by c squared. So a multiply by c squared and a divide by c squared just cancel each other out. So you're just going to be left with the b plus 4. It's very tempting for students in equations and formulas that have got squares in them to want to square root. Sometimes you do have to square root, but only if it's a subject letter, the letter you're trying to make the subject, that has a squared or a square root on it. In this case, it's another letter, so we can just move that letter and keep it as a squared. We don't actually need to square root in this case. So now we can just go ahead and subtract 4 from both sides. So remember, you're just always doing the same thing to both sides in these questions. So we get dc squared minus 4 equals b. And generally, they prefer if you spin this around to put the subject letter on the left. So the final formula, the final equation, after changing the subject, is b equals dc squared minus 4. So in question 8, we've been given this modified version of the sine graph, and we've been given a suggested formula. So instead of just being y equals sine x, which would give you a normal sine graph, this modified graph has got a formula a sine bx. And essentially we're trying to find the a and the b values based on the differences between this graph and the normal sine graph. So to answer this question, you need to know, first of all, what does a normal sine graph look like? So a normal sine graph is very similar to this one, but not quite the same. So a normal sine graph goes a little bit like this. Similar shape, a little bit flatter, and normally the top value, the maximum value is 1, the minimum value, like a cosine graph as well, is minus 1, and this end point where they've marked on here to be 45 is normally much bigger. It's normally 360. So whatever these values, a and b are, the presence of those values has changed this graph, which is just the graph of y equals sine x, into this graph here. So you just need to know how these positions of these letters, which are going to be number values, change the graph. So the first one is that this graph has been stretched up and down the way. So if it normally goes from 1 to minus 1, it's now been stretched to 3 and minus 3. That relates to the a value, which is called the amplitude. It's just how much the graph has been stretched by. So it's just been stretched by a factor of 3. So the a value is 3. This is a state question. There's no work in here. You just need to know how these different numbers and positions affect the graph. So that's the first one. It's been stretched by a factor of 3. This here is one cycle of the sine graph, but this whole cycle has occurred in 45 degrees, when normally it would be 360 degrees. This b value pertains to how many cycles you would get if you carry this graph all the way out to 360. It's related to the period. The normal period is 360. This one has been, has been changed. So you basically need to count how many 45s are there in 360, and that'll tell you how much the graph's been sort of squished by in a sort of horizontal manner. So if you start counting those up, you would get 2 45s in 90 degrees, and there's 4 of those, times 2. So that's going to be 8 of those in total. So you would get like 1 to 45, 2 to 90, and then 2 more to 180, so it's 4 in total, and then 2, and then 4 again to 360. So whatever way you count it, there's going to be 8 of those in total, so the b value is 8. In other words, this graph has been squished back the way by a factor of 8. If you divide 360 by 8, you will get 45. So that's all you've got to do for that one. Just state the values just based upon knowing what a normal graph looks like and how this modified graph works with the position of these numbers. So the first thing to notice in this question is we're dealing with a non-right angle triangle. Right angle triangle questions are generally going to be Pythagoras. If it's non-right angle, a general triangle like this one, then it's going to be the sine or the cosine rule. In this question, we're being asked to work out the cos of b. And notice that in this question we don't have any angles, but we do have all three side lengths. That's what you need to use that information to decide which of the sine or the cosine rule formulas to use. Now, the fact that we're working out cos b is a big hint that it's going to be the cosine rule. And the sine rule doesn't have any causes in it, so it has to really be the cosine rule. But the cosine rule has got two formulas in the formula sheet. The one that has got all three side lengths is the one for working out angles. On the formula sheet, it says that the cos of A, it's not the cos of B, it's the cos of A. So you've got to be careful with the letters, is equal to B squared plus C squared minus A squared over 2BC. And that's just on the formula sheet. So you've got to be careful because this question's ABC, but we're not being asked to work out cos A. So you can't use the formula sheet formula directly. We're going to have to modify it. But if you notice in this formula, whatever goes there, its small lowercase equivalent goes there, the other two letters go here, and they also go there. So just by modifying it, by kind of like just looking at it, you can figure out that if this is going to be a cos B, then the end letter will have to be a B squared. So that means that this needs to be an A squared and a C squared. Essentially, you're just swapping the A and the B, and this would become the B squared, and then that would be all over 2, no longer BC, but 2AC. So 2AC. So be really careful with the cosine rule. It's very sensitive to what angle or letter you're working with. The sine rule is less so. Sine rule doesn't really care about the letters. So at that point, we just now need to go ahead and plug in the values. Notice we're not being asked to work out B. We're not being asked to work out the angle B. You can't do that unless you've got a calculator. This is a non-calculator paper. So we're just going to put in the numbers, and then whatever we get here is going to be the answer for cos B. So remember that your small letters, your lowercase letters, are opposite the vertices, the corners. I've got the uppercase letters, so little a would be down here. It's always good practice to fully label these diagrams. Little b would be here, little c is up there. So our a squared, that's going to be 3 squared. Our c squared, well, c is 7, so it's going to be 7 squared. B is 5, so it's going to be 5 squared. Just by populating this equation at this point, you would already be generating marks. And then on the bottom line, we've got 2 times A, which is 3, times C, which is 7. So 2 times 3 times 7. Just a little bit of numeracy now, really, to try and simplify this. Just take your time with this. Don't be too ambitious. Just make each of these into a whole number. So 3 squared is 9. 4 squared is 7 squared is 49. And then 5 squared is 25. The bottom line, you could do that in one go, or again, take your time if you feel you need to. Don't know why I wrote 21 there, actually. That's just clearly not right, is it? So it should be 2 times 3 times 7. I think I was already calculating the 3 times 7, so that should be a 7 there. So yeah, 2 times 3 is 6, times 7 is 42. So we just put that in like this. And then just go ahead and calculate it. Some people like to just, this is a non-calculator paper. You've got to be careful when you say non-calculator. It's easy to make little mistakes. Some people prefer visually just to make that into a whole number first. So in other words, make the addition into a whole number. So that would become 58 minus 25. Whatever works for you. Some students are stronger with numeracy than others. Just do whatever is giving you the best chance of getting it correct. 58 minus 25 is 33. So this comes out to be 33 over 42. That probably looks like it's fully simplified, but because you've got an odd number and then an even number, but in this case I think that will simplify further, because you could divide this by 3 to get 11, and then 42 by 3 to get 14, I think. So yeah, 11 over 14 is the final answer for that one. Be really careful with sine and cosine rule, particularly cosine rule, for questions that are not asking you to work out angle A, or in this case it would be cos A, or side A, because the cosine rule formulas assume you're trying to find angle A or side A. If it's a deviation from that, you've got to rejig the formula or rejig the letters on your diagram. So the final answer for this one, cos B equals 11 over 14. So in question 10, we've got to do some percentage work and also a bit of numeracy. So percentage questions tend to be in the calculator paper. This time it's in the non-calc paper, so the percentage work will still be the same. The calculation will be more difficult because we've got to do it manually. So in this question, we're told that Tommy paid £16.10 for his flowers, I think it was, and that was with a 30% discount. And we're trying to work out the price if he did not get a discount. So what would the normal price be, the 100% price? So this is a classic reverse percentage question. So notice that if the 30% has been taken off, 30% discount, that means that what he's paid is equivalent to 70%. Because if you've got the 100% price, you take off 30%, you're left with 70%. So the way we're going to start this question is by saying that 70%, which is the price that the percentage equivalent of what Tommy has paid, is equal to 1610. And it's fine to drop the pound sign just now, we can put that in later on. Our goal in this question is to somehow figure out the 100% price based on this here. So usually the way we do this is by setting up a little equation like this, working down to say 1% or 10% or something like that, and then up to 100%. So the first thing we can do here is divide both sides by 10, just to simplify things a little. So that would take us down on this side to 7%. And just like an equation, we're going to do the same thing to both sides. If you divide 16.1 by 10, that would just move the decimal point to make it 1.61, like that. So what I want to do now is get this down to 1%, because I can't multiply 7 by any whole number to get 100, which is where I'm trying to get to. I want to take this down to 1% and get some answer for that, and then finally to multiply that answer by 100 to get up to 100%, which is what we're looking for. This is a tricky part of this calculation, dividing the 1.61 by 7. So this is going to involve a little bit of numeracy. So people will do this in different ways. It depends how you've sort of learned this, but one way you could do it, you could just think of it as being 161, like that, and just forget the decimal point. It's really up to you. Depends how you want to do it. 7 doesn't go into 1, but it does go into 16 2 times. So that would get 7 times 2 is 14, like this. And then we could subtract to get 21. 7 goes into 21 3 times. So remember that I had moved the decimal point essentially 2 places to achieve that. So this 23 would actually, the decimal point is there. I need to move that back 2 places. So the answer would be 0.23. So it's up to you whether you want to carry the decimal point into that calculation or not. Some people do, some people don't. Be careful with the numeracy, and that's how it's going to come out to be 0.23. So that takes us down to 1%. We're now trying to get up to 100%, so multiplying both sides by 100. That will just move the decimal point like 2 places to the right. So 0.23 will become, so 2 will become 23.0 or 23. So the final answer there is 23. This question's in pounds, so you need to then report the final answer and the 100% value as £23. So reverse percentages are not easy, but they do follow a very similar flow. You've got to start by interpreting the information to set them up like this, and then working through this, which is normally a calculator process, which would make this a lot easier to get to the 100% value, and then that is usually the number you're looking for. So the answer for this question is £23. In this question, we're being asked to simplify this expression, and we're going to achieve that using indices rule. So indices, remember, is to do with the powers, and there's a few rules you need to know, and this will be a very typical question in indices. So the first thing we're going to do here is to process the bracket part, and then later on we'll combine the two terms. Notice in the question, which is quite common in these questions, that they've said to write your answer with a positive power. So that tells you, that's a guide, that when you just first of all work out the answer, it should have a negative power. Because if they're saying write it with a positive, that's only because they want you to use a final indices rule to turn that negative power into a positive. If it was just going to come out to be a positive power anyway, they wouldn't write it. So that's an indication that there's going to be a final mark available for that, turning it back into a positive power. Also, we should get a negative power. So let's start with the bracket. So the rule here says if you've got a power on another power, so 2 powers separated by a bracket, you multiply the powers. So this is going to be equal to m minus 2 times 4 is minus 8. So m to the minus 8. And just leaving the other term the same. So you get 1 mark for that already. Now we're multiplying 2 terms together. If you're multiplying terms, remember they've got to have the same base. So in this case the base is m, but it could be a number or it could be some other letter. As long as it's the same, in this case we add the powers. So it's minus 8 plus minus 5, which is essentially minus 8 minus 5, which is negative 13. And at this point you've got 2 marks. So this has come out to have a negative power, which is what we were expecting. And to turn this into a positive power, you need to remember one more indices rule, which says that you can make that into an m to the 13, positive 13, but you've got to flip it into a fraction. So it has to be 1 over m to the 13. That rule, as simple as it seems, is notoriously forgotten by students. So be attentive to that rule, because it's going to get you 1 more mark for a very, very simple little move, but not easy to remember. But look out for that indication in the question about the positive power, because that tells you that your first part of working should come out with a negative power, and then you can just flip it into the positive power answer. So final answer for this one, 1 over m to the power of 13. In this question, we've been given these 2 algebraic fractions, and there's a divide in between them. We're trying to combine these into a single fraction and write it in a simplified form. So if you're ever dividing by a fraction, whether it's algebraic or numerical, there's a little trick for that, because if you've got, say, the fraction 2/3 and it's being divided by the fraction 4/5, what we normally do in that scenario is keep the first fraction, so keep the 2/3, turn the divide into a multiply, and then flip the second fraction to make what's called the reciprocal. Sometimes it's called keep, change, flip. So basically the second fraction gets flipped, and then you just carry on from there. And that's true regardless of whether it's a numerical fraction or an algebraic fraction. Once you get to that point, by the way, because you've turned it into a multiply, you can just multiply the numerators and the denominators. So this would then become 10 over 12, and in this case that would simplify down to 5 over 6. So we're going to do a similar thing over here, but it's all going to be done with algebraic fractions rather than numerical, but the process is the same. So we're going to keep the first fraction, so 4 over x plus 2. We're going to change the divide into a multiply, and we're going to flip to make the reciprocal of the other fraction, so that becomes x plus 2 all squared on the numerator over 5 on the denominator. So you probably get a mark for that already. So now, just like in the numerical case, now we're multiplying 2 fractions, so you can multiply the tops together and the bottoms together. So 4 times that bracket squared, I'm just going to achieve that by just writing 4x plus 2 squared. Notice that you can't multiply a 4 into a bracket or any number in a bracket if it's got a power on it. So this is not 4x plus 8 squared, okay? So that's a really important point. Now we need to multiply these together. To multiply those together, I've got a couple of choices. I could say 5 times x and 5 times 2 to give 5x plus 10. But in fact, it's going to be smarter here to just write it as 5 bracket x plus 2. And that's because when you've got an algebraic fraction and you want to simplify it, so we've now achieved the part of the question where we've combined our 2 fractions into 1. But when you're simplifying algebraic fractions, which is also they're asking us to do in the question, you need the numerator and the denominator to be factorized. So by keeping that in a bracket, it's already factorized, and now we can just work on simplifying it. And we can achieve this by thinking of that top line as 4x plus 2 all squared. In other words, if you're squaring a bracket, remember that just means the bracket multiplied to itself. In fact, anything squared is just the thing times itself. So that is another way of writing the numerator. The denominator I'm just going to keep the same, but by writing the numerator in that way, it makes it clear that we can then just divide top and bottom by x plus 2, or in other words, just cancel off those brackets like that, and that leaves us then just with 4 bracket x plus 2, and it's fine to leave that in a bracket over 5, and that's our final answer. In this third question, we're being asked to expand and simplify. The first thing you'll notice in this question, we've got different types of root number going on here. So you can only add and subtract surds if they're of the same type. So it's something that we don't need to be attentive to right at the very beginning of this question, but later on we will need to make them all the same type if we're going to combine them. It might be that once we start working, it will naturally become the same type of root, but keep in mind they've got to end up being the same type. So let's start by expanding the bracket. So even though these are root numbers, the bracket just expands in the same way. So we're multiplying the root 10 to the root 10 and the root 10 to the root 2, just like expanding a normal bracket. Root 10 times root 10, well that's root 10 squared. A square root and a squared cancel, so that just gives you 10. Or root 10 times root 10 is root 100, which is also 10. So either way, whichever way you think about that, that first term is going to be a 10. Root 10 times root 2, that is root 20. So if they're both roots, you can just multiply the numbers together like that. and the number on the end is just 8 root 5, that's just going to stay there. So 10, obviously there's nothing we can do about, we can't simplify that in any way, it's just a normal whole number. Root 20 we can simplify, root 5 we cannot because 5 is already a prime number. The root 20 is the one that we can take a bit further because we can make that into root 4 and root 5. And we could also make it root 10 and root 2, but we want to make it root 4, root 5 so that it matches up with the root 5 in the other term, and that's what we need if we're going to be able to add those together. So this 10 stays in the front, square root of 4 is 2, so that's 2 root 5 plus 8 root 5. So notice that I'll just keep the 10 in front actually for now. So notice that we've got minus 2 plus 8 root 5. So you're just totaling up how many root 5s you've got. Or you can think of that as 8 minus 2, whichever way is going to give you a positive 6. So it'll be plus 6 root 5. You don't need to add these or subtract them. They're just how many root 5s you've got. So if you've got, like, say, 4 root 5s, and you add to that 7 root 5s, that is just asking you to add up how many root 5s you've got. 4 plus 7 is 11. You've got 11 root 5s. Well, a lot of students will write that as 11 root 10. You don't need to do that, okay? So the final answer here is just 10 plus 6 root 5 because we cannot combine these. This is a surd number. This is just a normal whole number. There's nothing we can do to combine them. So that's the final answer for that question. In this question, we're being asked to sketch a graph of this function. So a lot of students will start these questions by going straight to the graph and trying to draw something. So we know that this, if you expanded out the brackets, you get an x squared term as part of the expression. So it's a quadratic function and they make U-shaped parabola graphs. So we know it's going to be a graph like that. We need to know where to put the graph. We can't just plonk it on an xy axis. We need to know some of the key points. And that's what they're asking in the question. They're asking you to identify those key points and draw the graph. So really you've got to find the points first before you can draw the graph. Drawing the graph is easy, it's trivial. Once you've got the points, you just fill in the shape of the graph. So although the question is sketch the graph, it's really an algebra question. Like sketching the graph is trivial once you've got the points. So there's several things that we need to find. So they're asking for the, first of all, or I'm going to do it first of all, they're asking for the y-intercept. So the y-intercept, remember, is where the parabola cuts over the y-axis. But if you're a point on the y-axis, your x-coordinate is 0. So for the y-intercept, you're just going to let the x value be 0 in the equation. So that means that you're going to substitute 0 in the place of the x's. So you're going to get 0 plus 1, and then 0 minus 3, and then we just need to calculate that. So 0 plus 1 is just 1, 0 minus 3 is minus 3, multiply those together, and we get negative 3. So that is when x was 0 and y is negative 3, so that tells us that full coordinate for the y-intercept is 0, negative 3, okay? Secondly, for the x-intercepts, which is just another way of saying the roots, so the x-intercepts and the roots are the same thing. I like to sometimes call it the x-intercepts because it means that it's more aligned with the terminology y-intercept, and it also helps students sometimes to remember that you just always do the opposite equal to 0. So if it's the y-intercept, the x equals 0. If it's the x-intercepts, or the roots, then you're going to let the y be 0. So if you put a 0 into the formula for y, just in the same way we put a 0 here for x, we're going to get 0 there for y equals x plus 1, x minus 3. Normally when we've got equations like this, the zeros on the other side, it doesn't matter what side you put it on. So you might, I mean, if that looks weird to you, you might just want to put the 0 on the other side. So a lot of students do that because they're more used to seeing it like that. And because they've already factorized this for you, this is close to being solved already. So we're just splitting these off, remember, into two little mini equations. So we get x plus 1 equals 0, and we get x minus 3 equals 0, given a solution here of x equals negative 1, and a solution here of x equals positive 3. Now these are two separate points. This was 1 point. These are 2 points, and their y-coordinate is 0 in both cases. So the full coordinates here are minus 1, 0, and 3, 0. A really common mistake that I see a lot of students make, they find these 2 points, the roots, but they think of them as one single point. They think this is a point minus 1, 3 or 3 minus 1, but it's two separate points, okay? So 2 root points, 1 y-intercept. The other thing they want in this question is the turning point. So the turning point always occurs right between the two roots. So we could actually at this point maybe start to draw our sketch just to get a little bit orientated. So we can start it just by marking on the points that we've got so far. So this point here is at -3 on the y-axis, so that'll be like 1, 2, 3 down the way. So maybe like roughly there. This point is at -1 on the x, so that'll be like roughly there. This point is at 3 on the x, so 1, 2, 3, roughly there. These parabolas, remember, are symmetrical, so our parabola is going to come down here, turn somewhere like here, and then go back up. So the turning point is approximately going to be in there somewhere, but the important thing is it's got to be right between the two roots. So this root here was the one which was at -1, so this was the point at -1, 0, this was the point at 3, 0. To find the midpoint of those two, add them together and divide by 2. So -1 plus 3 is 2, divide that by 2 is 1, so it tells you the midpoint is at 1. So in terms of the turning point, we now know that its x-coordinate is going to be 1 because it's the midpoint of those two roots. Okay, to find the y-coordinate of the turning point, you need to substitute the 1, which is the x-coordinate, into the formula in the same way that we substituted 0 into the formula earlier to get the y-intercept. So you might want to show that as a bit of working, so that's going to be x equals, so it's going to be 1 plus 1, because we're putting 1 in for x, and then it's going to be 1 minus 3, and we already expect the turning point to be down here somewhere, keeping in mind that this point here was at keeping in mind that this point here was at -3, we should find that it makes sense in terms of all of the points. So if we look at this guy here, we get 1 plus 1, which is 2. We get 1 minus 3, which is -2, multiply those together to get -4. So the turning point is at 1 minus 4. Now, if we figure that 1 minus 4 would be about there, that does fit in with the other points. It's really important to get the points to all fit in to make sense. If you get one of these calculations wrong, you're going to get a point that doesn't fit in with the other points and doesn't make a parabola. So now we can see that we can just fit in the parabola graph like this. So you can see that these questions are not really about drawing the graph. Like a monkey can draw the graph, it's just a case of finding the points. So the thing to take from this question, and quadratics and parabolas are tough, it's a tough topic, but a really, really key point that might help you is that the y-intercept occurs where x is 0, the roots or the x-intercepts occurs where y is 0. So always the opposite letter equivalent to 0, and the turning point is always right between the two roots. So that's a sketch of this quadratic function. So in this question we've been given these two shapes, a triangle and a rectangle, and notice that the dimensions include variables, include x's, so we're not looking at just numerical values here, which is very typical of a question like this. So in the first part of the question we're asked to work with a triangle, and we're asked to make an expression for the area. Notice that they use the word expression rather than just find the area, because the area is going to contain the x. We can't actually work it out as a numerical value because we don't have this as a numerical value. So to find the area of that triangle, we need to know a formula for finding the area of a triangle of that nature. And the formula, which you do just need to know because it's not on the formula sheet, is 1/2 times the base times the height. So we can just, once you remember that formula, you can just go ahead and plug these values in. So it's going to be 1/2, I'm just going to introduce a multiply sign. So 1/2 times 3, which is the base, times the height, which is x plus 12. Just going to keep that in a bracket, x plus 12. Notice that this part of the question, part A, is only 1 mark, so there can't be a huge amount of work to do. 1/2 times 3 is 3 over 2, or 1.5, but probably best to stick with the fraction, so 3 over 2, bracket x plus 12. And that's fine, you can leave it like that, you don't have to multiply out the bracket. If you do multiply out the bracket, it wouldn't mark you down for that, but it just introduces the chance of making a mistake, and it's fine already at that point, so just leave it probably at that point. Part B of the question, which is the main part, is more demanding. In part B, they're telling us that the area of the rectangle is equal to the area of the triangle. So that's essentially saying that the area of the triangle is equal to the area of the rectangle. And questions like this are difficult to get going. Students often don't know how to start these, but if they're telling you that two things are equal, or if they use the word or words of the nature of like same, or words like equal, they're basically guiding you towards making an equation, because you can only solve generally for values from equations. So we're trying to solve for the x value in this part of the question. We're going to need an equation that contains the x to then solve for the x, and that's what this really is the starting point of our equation. We just need to fill these in now and then solve our equation. The area of the rectangle, the area of the triangle we've already got, so that is given by 3 over 2 x plus 12. The x can be a little bit confusing because normally we're thinking of areas as numerical values, but this is saying that this is an expression, a formula for the area. So if you want any x value in here, you just put it in there and then you work it out, and that gives you a numerical value for the area. So this is an expression for the area. We want to do the same for the area of the rectangle. Rectangle's formula is just the length times the breadth, or basically the two sides multiplied together. So that's going to be 6 multiplied to 8 minus x. So 8 minus x, just like that. And then that basically gives us our equation, which if we then solve, will give us our x value. So different ways to do this: you could multiply the brackets, or you could multiply by 2 to get rid of the fraction. So either way there would be fine. I think what I'll do is pros and cons with actually. You've got to be careful with the numeracy either way, but I think I'll multiply both sides by 2. So this is all one term, so if I multiply that term by 2, it just gets rid of the divide by 2. So that would just leave me with 3 bracket x plus 12. Multiplying this by 2 would make it 12 times that bracket, like that, okay? But you could also, like I say, do that by multiplying out the bracket. It really is up to you. So at this point, we're now going to just multiply out the bracket. So 3 times x is 3x. 3 times 12 is 36. Got to be careful with the numeracy because it's a non-calc paper. 12 times 8 that's 10 times 8 plus 2 times 8. 10 times 8 is 80. 2 times 8 is 16. 80 plus 16 is 96. And then 12 times x is 12x. This is just a normal linear equation, so it's gathering the terms, or x terms on one side, numbers on the other. If we add 12x to both sides, you would get 3x plus 12x to give you 15x. And then on the other side of the equation, if we subtract 36 over, so subtracting 36 from both sides, 96 minus 36 would give us 60, like that. And then to solve it, we just divide both sides by 15. So 60 over 15. Normally in questions like this, it doesn't have to be, but normally in questions of this nature, the x value will come out to be a whole number. And that's kind of partly as a self-check mechanism. So if this comes out to be some weird answer like 60 over 11, which wouldn't simplify, that's probably an indication that it's wrong. If it comes out to be 60 over 15, which does simplify because 15 goes into 64 times, so you get this nice reassuring whole number, that's probably an indication that you've done it right. So in this case, that is right. So x does equal 4 in this case. The trickiness with a question like this is really knowing how to form that and to form that. Usually most students are fine with this part, or mostly fine with this part, but it's getting to that point that can be tricky. So this is where you're going to look out for keywords like same or equal, telling you basically to form an equation, stick the things that they're talking about on either side of the equation, and then sort of take it from there. But not easy. That's why it's a final question in the paper, because it is meant to be more demanding. So that is the answer for part B, x equals 4.